Tēnā koutou katoa. Good afternoon. Thank you so much for joining us after lunch. We're starting with a presentation by Thomas Berger from NeSI. He's a product manager at NeSI. And the title of his presentation is Building Custom Web Portals for HPC and Mid-Tier Computing. Over to Thomas.
Greetings, kia ora, koutou katoa. As Nisha said, my name is Thomas Berger. I'm in the role of a product manager at New Zealand eScience Infrastructure, and my presentation is about building customized web portals for HPC and mid-tier computing with Open On Demand, empowering researchers with seamless access. So the objectives for this presentation are a flexible HPC at NeSI overview, a brief overview of the eResearch NeSI partnership, DevOps practice and infrastructure as code, the human-centered design approach, and finally sharing the details of the Open On Demand customizations. The NeSI Flexible HPC platform is a private OpenStack-based cloud environment supporting both HPC and mid-tier computing. Mid-tier computing is not supercomputing or large-scale specialized HPC, but it is bigger than a laptop or desktop. Mid-tier computing requirements are often fulfilled by in ad hoc ways by things like large workstations or loosely coupled department or group clusters, both of which have less desirable organizational outcomes than a shared platform. The NeSI Flexible HPC core has enabled eResearch to invest in dedicated resources delivered as services by NeSI. Mid-tier institutional eResearch platforms allow for deep campus integrations, enabling seamless access. The compute resources can be made available with a flexible provisioning model. The eResearch infrastructure, ERI, compute cluster consists of login nodes, a Slurm workload scheduler, Open On Demand, cold front allocation and resource management, a identity management component with integrated Active Directory Trust, plus virtual networking, supported by our vendor Stack HPC. The compute cluster is connected to a GPFS-based storage system with integrated data management framework to automatically shift data to lower tier storage. The eResearch ERI compute cluster is defined as infrastructure as code. Here's an example of a merge request for Open On Demand as part of the cluster deployment. Changes happening in a code repository and are tracked by merge requests. This way we are enabling transparent collaboration and across teams and as well as change management. So while we are dealing with a fairly complex technical implementation, we build it for humans. And human-centered design is a practice where we focus on 4 key aspects. We focus on the people and their context. We seek to understand and solve the right problems. We understand that everything is a complex system with interconnected parts, and we acknowledge that this is a continuous process. So Open On Demand can be described as providing access to your organization's computational resources via web browser. No client software installation is required. Start computing immediately. A simple interface makes Open On Demand easy to use and to learn. launch on any device with a browser, if you really want, even on a mobile phone or a tablet. Open on Demand supports presenting apps as cards. So the screenshot shows multiple cards here. And users can launch an instance of these apps in a very simplistic way. These apps would require SSH tunnels and proxying connections on the NeSI legacy HPC platform. Open on Demand is simplifying the HPC access to scheduled compute resources for both interactive and non-interactive workloads. Users can leverage job submission templates, browse the project directory, access files, visualize results using available apps. Let me show some example screenshots of applications. Here, very simple Linux-based remote desktop application. A more specific application called Integrative Genomics Viewer. Or a more common example of the Jupyter Lab app, all hosted by Open on Demand. So users can see all the interactive sessions in one view, and in the same view, they can also relaunch existing or previously launched sessions with an easy one-click approach. In the same interface, there's also a link to see all the log files and metadata basically that's generated by the previous session. Open on Demand allows also to link to Grafana dashboards. And this is to inform the users about job efficiency or how busy the cluster nodes are. So you can see there's many levels of details we can share with the users and inform how they interact with the cluster. Open on Demand is made up of the platform consisting of Apache and Nginx mostly, passenger apps and plugins. Passenger apps can be Ruby apps, Python web apps, or Node.js apps that follow a convention for the app's startup file. Open on Demand interactive apps are plugins that contain a configuration file and a job template for running a VNC server or web server application on a compute node. Examples would be Jupyter Lab or MATLAB. Open on Demand publishes a variety of apps or app recipes on their website in a directory on the website. So you can see in the screenshot there's a few cards visible. So if somebody wants, for example, an instance of a RStudio hosted via Open on Demand, there's a recipe out there and just need to customize for your computational resources. Open on Demand has a worldwide community using it. And I'm curious, who here is already using Open on Demand? Maybe a show of hands. Not many. Okay, a few. And anybody maybe has installed Open on Demand or is maintaining an installation? Cool. So if you don't see yourself represented with one of those 3 dots in New Zealand, share it with the Open on Demand team. They will happily put another dot for us on the map. So the customizations, we focused around, in the first instance, around message of the day and the help menu, and a little bit of the UI. So context help and links can be easily added, for example, to link to the relevant documentation or the user feedback portal. It is also possible to add a role or team-based guidance pages, so-called profile pages, to the system. So if you have a department or a group and there's specific information that should be relevant for this group, you can host a page within Open On Demand in a profile page. Incident and scheduled maintenance communication can be integrated and displayed using, in our example, the status page widget. And as I mentioned, the branding can be fully customized. Here are a few examples of where we link to. This showing our feedback portal link where users can share feedback about existing features or suggest some new functionality. Similar, our user support request option in the support portal. All right, moving on to ColdFront. ColdFront is a open source resource and allocation management system designed to provide a central portal for administration, reporting, and measuring scientific impact of cyber infrastructure resources. Using ColdFront, we enable self-service for project teams. So PIs or project owners can check the current state of their projects and their allocations, and they can add or remove project and allocation members, therefore grant access or revoke access to the allocated storage or compute resources. So users can be linking from ColdFront using that icon of Open On Demand that's displayed in the ColdFront interface. So therefore, there's an easy link to access the compute resources exposed by Open On Demand. Learnings so far with the ColdFront integration, the synchronization with Slurm accounting and free IPA groups is available out of the box via plugins. However, we had to customize it because in our integration with eResearch, we had to use or enable Active Directory user accounts. One shortcoming is that there is no support for multiple organizations use cases out of the box, but the plugin architecture allows for extension. The ColdFront project is also open source and community supported. Thank you for your attention. Happy to take some questions.
So how does Open On Demand handle queuing if you end up with like too many users and you need to queue? Does it have something?
Yeah, so I mentioned the Slurm workload scheduler. There's options where you can branch out and say, okay, I want sessions only running on that Open On Demand, which is similar to a login node, basically with some extras. And there's also an option now that you can put workload on a Kubernetes cluster. So you have the choice when you install the system to set up a card or an app that utilizes resources in one or the other way. Yeah. There was another question?
It was the same question.
Okay, same question. Yes, go ahead.
What's involved in setting up a card, like if you've got some sort of service that needs to be started or something like that? How do you make that into a card?
If it's featured on that directory I mentioned, then it's fairly easy. You basically customize your cluster name and maybe specify the partitions you want to use for that specific app. And then you have to make a decision whether you want to pre-configure it with amount of RAM and the time slot it should use, or whether the user should have the options. So that's the easy part. If you have an app that's not there yet, then it's a little bit more work, and so you need to make sure that these startup configuration files adhere to the standards. Yeah, another one from the back.
I don't know how closely you track usage, but
But it's definitely both, but what I didn't show here is there's a shell in the web browser available as well. So that's one of the very most common and used features, I would say, to really have a simple, easy access way to a shell, no configuration on your machine required. Yeah. All right. Nisha, are you wrapping it up? Thank you. And thanks everybody again, and happy to stay in touch. Send us, drop us a note, send us a message to support Cloud NeSI org/NZ, or yeah, send me an email, whatever works for you. Thank you.
Okay, thank you so much for coming over here and supporting Michael. Michael's our next speaker. The title of his presentation is What Happens After You Turn on the Flashlight, Building Security Capability. Michael Karich is from the University of Auckland and NeSI. Over to you, Michael.
Thank you. I'm probably loud enough to not need the microphone, but if I drift away and you can't hear me, wave a hand or something, and I'll make sure that I get closer or talk louder. So as Nisha said, I hold many hats, but the one that I'm speaking from today is as the Deputy Chief Information Security Officer for the University of Auckland, where I'm tasked with sort of protecting all the research that the University of Auckland does. They're a research-centric university, and a lot of data passes through their doors that we have an obligation to protect. So I want to outline a bit of the challenge, sort of what goes into making research happen, how we have seen a problem, what we did to turn on the flashlight, what we found when we turned on the flashlight and we saw all those cockroaches skitter around, and then what we're trying to do to solve it, because it's not just a University of Auckland problem, it's a research problem that happens internationally. And I think people are just now starting to, the light bulbs going off, like that's a risk that we're actually gonna have to solve. We can't just keep kicking that can down the road. So our challenge is to sustainably secure a vast and variable research ecosystem. Every researcher needs different things at different times and at different speeds to do what they're doing. And as more research involves compute, even as you get into the arts and the histories that weren't traditionally compute heavy, now they're using it. And how do you secure that? So they have their an unending mix of the OS and the applications and the software and accessibility, whether that's private, public, whether it's shared, whether it's highly available. They might need it for 2 months. They might need it for 10 years. You don't know when you start the project. And it normally changes at least 3 times throughout the life of the project. Well, most university enterprise ITs are designed to deliver a defined set of services. It's static. It's meant to serve the business. Your email, your web pages, your authentication, your course registration, the things that just have to work to serve the staff and student needs. And so we also have governance. We all get our research funding from around the world now, from many different sources that want us to protect that data. It used to be just kind of the university's prerogative, maybe their IRB, their human protection, their cybersecurity team. They'd outlay some frameworks that you needed to do or would do for you. Well, now you have NIH, NSF, TRPSR, HESO, the Privacy Act, and the Health Information Privacy Code. All of these different things have a varying degree of controls and how they're defined. And so it's a complicated task when you have a project that's subject to multiple of those governance structures. So what goes into determining the security of research efforts? So there's the research itself. It has to be adaptable, it has to be rapid, which doesn't go hand in hand with protecting something. Normally you want to put up as big a walls as possible and keep everybody who's not supposed to be inside those walls out. Doesn't work when you're constantly changing the field you're working in. The infrastructure, it's all over the place, how it's managed, how available it is. It could be oversubscribed, it could require a complicated process, a very lengthy design session around gaining access to that, which slows down or hinders research. Governance, it's vague. Most researchers don't understand the governance structures from their funding organizations. It's complicated, and it's continually changing. They just want to do the research. And so, right, that equals easy compliance. We put all that together, and everything's happy. Not right now, it's not. We want to get it to be user serviceable and manageable at scale. We have several thousand researchers at the University of Auckland. We have a couple hundred technical staff. We have even fewer research-focused technical staff. How do you take those skill sets of securing a custom-developed code base that's running on some obscure minor version of Debian where if you change any of those variables, it breaks? But there's still underlying securities in some of those supporting packages. How do you keep enabling that research? So at UA, we have two primary platforms that we enable research through. Nectar Cloud is one of them. Our Center for eResearch manages and maintains that. It's really open and flexible. Every researcher gets their own little sandbox to do what they want to do with. And then it's their sandbox. They own it. That raises some alarms for what we look at next. We have enterprise VMs. This is where our architecture teams are going to meet with a researcher. Tell me what you need. I'll design the networks, the backup schedule, and we're going to have this 6-month planning session, and we're going to give you a VM that will always be on and always be up to date. But 6 months' time, the plan changes, and then you start that cycle over again. And there's also others. We still have a very, not invasive, but deeply embedded culture where researchers are just gonna do what they're gonna do. They have a credit card, they're gonna go buy what they need because they need to move forward and deliver to their funders. So I love animations, but we turned on the light. There's not too many more of those cheesy ones, but they are fun. So I'm gonna walk through how we took that challenge of figuring out what it was that we had and the state it was in. So we started with network scanning with Run Zero. So this is an agentless network tool that monitors traffic that flows. So we can detect systems, host names, types of traffic, applications, all that metadata that gets embedded in network communication. Run Zero can start building a picture of what we have on our network. From there, we generate a list of systems. We know where the traffic is coming and going. Then we can use Tenable to do agentless scanning. We're working towards agent-based scanning, which gives us an even deeper picture into what's on these hosts, but this gives us a very high-level view based on what anybody on the network could see. To give us some more in-depth there, we've leveraged a tool called UpGuard to do scanning of our public interfaces. This does routine, regular score assessment of common vulnerabilities and the stacks that are presented to the public from our public-facing infrastructure. And we're doing reporting. Right now it's very manual. The teams have to tag and identify and put these systems together and then create reports. And there's a lot of resource burn to take this massive mountain of data and get it out to people who can act on it. Well, so what we found, for example, if my slides are going to work, we found 309. This is just on the Nectar platform itself, 309 instances of a vulnerability for Server 2012, R2. For those of you that aren't in the tech space, that server edition has already been marked end of life and should not be used. So that means we have 309 instances just on the Nectar platform that are using an out-of-date operating system. There's a lot of numbers here, but the biggest one that's super scary is there's 63,000 vulnerabilities that are exploitable that were found on this platform. It's a really big number. It's almost so big that you can't start to begin how to solve that challenge. And so we looked at these numbers, we picked our jaws up off the floor. We kind of wanted to make sure that these were right, so we ran them again, we made sure they stayed steady. And we came up with some potential paths. So we turned it off. We just, it's the PI's problem. It's their work. If they lose their data, tough cookies, we give them the resources to back that up and protect it. We could send vulnerability reports and let the researchers resolve them. We'll keep the flashlight, but we'll hand even more keys to the researcher and say, do your research and become system administrators. We can just turn it off the internet for some of these systems. Yes, it protects the data, but it stops the research. So we can staff to support the researchers in addressing those vulnerabilities. And we can take those vulnerabilities and own them as a technical team to resolve, manage, and move them forward. So some of these clearly weren't going to work, and I'm going to walk you through a little bit of the whys. It's a massive risk. We can't just turn off we opened that can of worms, we know it's there, we have to address it. We just can't turn the light back off. We can't just send them vulnerability reports and say, fix this. They don't know how. They have all of these OSs that they need to manage. They have these massive code bases. You've got a graduate student that creates this research program, does great. They need to keep it available, but the researcher has gone on to his postdoc at another university. The supervisor doesn't have the technical expertise to continue that forward. We can't just turn it off. It's very punitive. It kind of decreases that trust. Service delivery teams spend a lot of effort building and maintaining that relationship with their researchers. We can't just say, ha ha, you failed, we're taking this away from you. It would immediately erode that trust, and they would just go do something else. Number 4, it's kind of balanced. If we find staff to help automate and fill that middle ground and then support code changes, maybe that'll work. And lastly, it's not scalable to just ever increase our number of technical resources as our number of researchers increase. We have a very limited talent pool here in New Zealand of members who are capable of doing the technical work to manage, automate, and patch these very complicated and complex platforms. Not anybody can just do that, and it's very expensive and challenging to get people here. I'm one of the outliers, as I recently migrated from the US. So it is possible, but it's not scalable. So how do you actually make it sustainable? So in CER, we are starting with a contract security engineer. It's a role that was brought on board for a fixed term to automate, to understand, to investigate, and build the processes to patch as much of it as we can, as automatically as we can. Realistically, we can probably do 80% of the systems with automated patching. We can enroll them in vulnerability scanning, we can enroll them in automated patching platforms, and cut that 63,000 number probably down to less than a few thousand. Because most of those have been patched by the vendors through new versions of their software. Hopefully, this person and this role works in this capacity, and our researchers like it, and we can continue to expand this out. Because at the University of Auckland, we're working towards an ISSO, so an Information Systems Security Officer sort of role, hat, whatever you want to call it, depending on the delivery team, to embed security practices into the team. We don't want to be a gatekeeper as a security team. It's not scalable. 0.5 on the last slide. We have to scale it and have those localized focused researches. And then our last big effort that we're trying here is that we need to understand and quantify the data we have so that we know to protect it. If we have 50% of our systems that are only working with public data that's already somewhere else, we don't care as much about the sensitivity and the protection of that public data. Whereas as we move into more sensitive data, we have to protect it, but we have to know what that data is first. And so we're working through all our platforms. We're evaluating them based on the data needs of the users, and we're assigning them a data classification in accordance with our policy. So we can say, this platform is good for this type of data, and provide sort of that ease of use, that visibility into what we offer to make it easier for researchers and to ease the management of our platforms. Ideally, as that scales up, we can do usage tracking from a network level. So we can tell if this one SaaS application that somebody was using 5 years ago, is it still being used? Do we still need to care about it? Or can we turn it off? Can we turn off our monitoring of it? So there are some things still in the dark. Endpoints, personal device, user devices, workstations, things like that, third-party services and the data held within them, and subcontractors on research contracts. We don't have a lot of visibility there. And we are working very closely with our centralized research departments and our distributed research teams to slowly build the processes and visibility into protecting all of that landscape. So, questions? Okay on time? Yeah. Yeah, right here.
How do you think your journey or your statistics compare to other universities?
It's hard to compare. Not many universities publish what they are, and especially here in New Zealand, I'm not sure many have the statistics to compare them to, focused on the research landscape. There's a lot of work that Enterprise IT are doing for their staff side. The research has sort of been left behind. But I would say that anybody with a Nectar crowd, it's probably very similar. Another question?
Yeah, I was wondering what happens when you inform your senior leadership team. How do you do that? So in a way that they can understand the risk that the university's at by sort of limiting the vulnerabilities you're finding?
Yeah, so it's a very similar sort of presentation that we used with our leadership. We quantified what we had, what we needed to do to protect it, outlaid sort of how we could do that, which resulted in a staff, a contract role with our Center for eResearch to sort of serve as a use case, a white paper model of what we could do to protect other groups and other research entities across the university. We've been very fortunate that our Vice Chancellor has been increasingly supportive of investing in security. Some of the recent incidents that have happened across the area have really given a lot of spotlight to it that has helped play our story. And so we are starting to see a broader investment and focus and understanding that security is important and it's challenging and we have to address it, but we can't just run in and start closing doors. Yeah?
What other sort of functions across the university that you needed to collaborate with rather than it just being an IT shop in order to manage some of the associated risks? I guess I'm thinking of, potentially the data sources that are sensitive, that in fact those that supply those data, that data may be a little bit concerned about those vulnerabilities existing.
Yeah, so that's a great question, and I think the answer to that is it's a shorter list of who we haven't had to collaborate with. Because if we just outroll mandates, nobody's going to follow. We have to build support, build the momentum. So we've worked with our ethics committees, work with our contracting teams, work with our central research organization to really understand the interaction points, to get a feed from our contracting team to see what is listed on that contract as sort of the requirements and how that feeds into the service delivery teams, because it's not always IT that's involved in the service delivery. It could be a smaller research team. It could be an external organization like NeSI that we need to partner with to understand how that service is compliant, and then work with the researchers themselves to make sure that we're not building too many walls and that we are making the pathways clear, identified, and walkable. Yeah?
I have a question around, you said that one of the things that's happening is looking at systems and classifying these different types of data classifications. Are there frameworks that you're using to do that in terms of if data is at a certain classification, what security requirements or what specifications are you kind of forming to in
Yeah, so we are building all of our frameworks off of NIST so that they can be easily replicated at other universities. We don't need to reinvent the wheel. NIST has already put in the big work to do that. So 805.3 is one of the frameworks that we're using for our internal classification, and we're going to use some subset of 801.7.1 Rev 2 for our sensitive data. For those of you familiar with those frameworks, we're probably not going to use all 110 controls because that just becomes a little bit onerous, but we are looking at some of the subsets of that, and that there are efforts to take those frameworks and map them to the Privacy Act, map them to the Health Information Protection Act, map them to HISO, so that way we can have a crosswalk that says, here's how the practices, processes, and protections that we put in place map across all of those frameworks and demonstrate our compliance. Yeah?
Who actually turns on the flashlight, or decides to turn on the flashlight?
So at Auckland, it was the security team. We have been slowly building up the capability to give that visibility to the service teams. And eventually what we see ourselves working towards is the security team provides the tools, the training, the capability, the connection, and that each ISSO or delivery team leverages them to manage and patch and maintain what they're responsible for.
We ran Tenable across our fleet as well and got sort of similar bits to numbers. And our prioritisation was sort of like an 80-20, where we tried to knock off the 80% of the vulnerabilities that was kind of easy, and the last 20's taken 100% of the time.
Yep.
What was your prioritisation process for your numbers?
So we started with our public-facing infrastructure across the entire org. So we worked with more of our UpGuard scans. With those, due to their public nature, we took a very aggressive approach, and that if we weren't able to be given a reasonable deadline of addressment, we turned off their internet access. So for that public accessibility, we took a more hardline approach, and it really was that same 80-20 split. You know, a lot of it could be easily patched. You run your Yum update, you run Windows Updater, and most of them get fixed. The CER role is really focusing on that internal, those challenging ones, and so it's how you help those tough ones that really takes the most resources. And we've struggled with it as well. So if you've had success, I want to hear about that. Yeah. Well, I do think I'm taking away from break time. I've loved all the questions, and if anybody wants to have more conversations about it, please reach out. I'm always available and want to share, want to partner, want to collaborate. But thank you for your attention.
Okay. Yeah, okay. So I was just asked to introduce myself. I'm Professor Richard Sinnott. I head up eResearch activities at the University of Melbourne. I have a team of about 40 software engineers working on all kinds of different stuff. I guess the main focus, if I had to say what we do, is data and security. So we have big projects with defense, big projects with intelligence agencies, and a whole bucket load of medical-related projects, some of which have gone viral, global, I guess you can say, used by hundreds of hospitals around the world. So I do a lot of work in access and usage of sensitive data. So what do we learn from this? So most of my projects, when people come to me for medical-related research, more often than not, it's about data, accessing data that's hidden behind a firewall or in a government agency, etc. And we need to find ways to pull it all together to make it all look like it's just sitting on a website or a web portal. Fine-grained access control about who can access what, once it's being pulled together. And that includes anonymization at source or pseudo-anonymization or some sort of approach whereby they need access to the data, but they want to link it with other data. So how do we do that in a privacy-preserving manner? We do a lot of that kind of stuff, I guess, at the end of the day. All of the work we generally do has got, well, it has to have ethics around it. We don't just grab sensitive data. Unless it's social media, then we do whatever we want because everyone else is, and we have lots and lots of that. But normally there is documentation about what data you're trying to collect, why you're trying to collect it, is it approved to be collected, and what can you do with it downstream. And so there are various processes which we have to abide by. In Australia, it's probably different in New Zealand. We have states and territories, and they all have different recipes, different ideas, what's private and what can be shared and can't be shared. But we need to have all of these boxes ticked, basically, before we apply any kind of technical solutions on our side. And it's about building relationships and trust with a lot of the hospitals and a lot of the government agencies we work with. We often speak a language they don't. They have a thing called a firewall and a website, and somewhere inside that organization there are databases with sensitive data, and we need to build ways to access and use that data. And that's more than just tech. It's actually engaging with them and understanding their risks and concerns. A very brief word about the data I deal with. I've probably been to more hospitals than most people. Touch wood, I don't get sick very often, if at all. Every single site is different. Every site has a latest, greatest Epic system or Cerner system or this wonderful new system that's coming soon, and it's always a dog's dinner, if I'm brutally honest. It's never a wonderful system that all the hospital, the researchers, the clinicians, they use the systems and it does all their things. More often than not, it does some of the things they need to do for the running of the organization, let's say. But when it comes down to their research, they typically have a go at building their own spreadsheets or things they collect as part of their day jobs that the systems they have inside the hospital just don't do well. So, and it's nearly always, as I say, there is no schema. There's been lots of schemas. There's HL7, there's ICD. I can take vocabulary extraordinaire, but there are many different people around the world who are collecting data. And these data sets are collected in using different coding systems for different purposes, and somewhere along the lines they want it all to be glued together. And that's kind of what I do. That's well, not me personally, but I have a bunch of techies who are very good at that kind of stuff. So that's kind of the space in which I operate. There are many, many technical solutions we've built over time to integrate data, to access data. If you can just talk to all these remote databases, like federated querying, that's great, but that never happens in many medical projects. An alternative is we just build some sort of external web application. So you can log in, you give your username and password and privileges. You log in, you enter information about your patients, and that's very successful. It doesn't have to talk to local hospital systems, and so it's very easy for me to build those kind of systems. And that works for many scenarios, like rare cancers and rare data, etc., where there's not a massive expectation of double data entry. Whereas for many conditions like diabetes and certain more common cancer types, they're never going to enter all the data into their hospital systems and then log into some other system and enter it all again. So we have, well, I guess I call it push-based systems for doing that. We get the data from the hospital into our systems, and then we process it and clean it and do all the things we need to do to it. And they can then start integrate. We do that many, many times with many hospitals. And I'm going to talk about one project in this space, which is the Australia and New Zealand, Diabetes Data Network, which is a national platform which my team build and host and run, where we're integrating data from many, many hospitals, children and adult hospitals across Australia and New Zealand. So just a bit of background, this project's been going on for quite a long time. I seem to have cornered the market in type 1 diabetes. I have maybe half a dozen projects, all multi-million-dollar things, which are running, collecting national screening, and if you know anything about MRFFs, we have a bucket load of MRFFs as well. There's a big mega project in Australia to do medical research. But we have about 21,000 patients, and we're tracking them over time. We've gone to the big centres to start with. So in Melbourne, for example, there's the Royal Melbourne Hospital or the Royal Children's Hospital. There are lots of smaller private hospitals, but they're the big ones where most people tend to go. And similarly with other major cities around the states and territories. There are lots of the main place you go to if you have diabetes, let's say. And so we are getting exports of data from a whole range of hospitals, both adult, and as well as pediatric. Initially, the focus of the project was pediatric, but we've since grown to accommodate more adult sites as well. The way the process typically works is a patient goes to a hospital, goes for a checkup, or just, I'm not feeling well, or whatever the situation might be. They get diagnosed with type 1 diabetes, which is a genetic condition, and they then sign, well, there's this national registry we've established, would you be willing to be involved? They sign a piece of paper, or they just agree, yes, I'm happy to be. And then we get that consent. It's captured once at source by the patients at the hospital. And thereafter, when we get the next data upload from the hospital, that patient's data will be included. So, and all of that is kind of part of our, I mean, I don't see the pieces of paper from any random hospital. All I know is the data we're getting. The patients have agreed that their data can be used to go into the registry. And so we have a national ethics approval for this through HREC. Don't have to worry about the acronyms, but we have approval for this. We're capturing a range of data, which is it's a really interesting project from many ways. So we never need to track the individual. This is all about national patterns in data, about national benchmarking, about getting all this data together to run big questions across how the population faring with this condition, and does this technology, so continuous glucose monitors, which you may have heard of, is that better than any particular brand of insulin and things like this? So we don't care about tracking an individual. We care about all the data being used collectively to answer big research questions. We get many, many visits per patient. So you have people in the system that first were diagnosed 20 years ago, and they've been going every few months for a checkup. And we have this longitudinal data on these individuals. We're tracking a whole variety of data. Again, we have a data dictionary which comprises maybe 500 data points or so. Hospitals collect 10,000 data points, so 50 data points. But we somehow have to write the software that takes the data they're collecting, map it into the data that the community, the diabetes community involved in the project want, and then we can then do benchmarking because it's all comparable then. Just to give you an example of what it looks like, they come along with their spreadsheets or their whatever XML format, or which we deal with whatever they have. They're not going to re-engineer their systems because we want their data. We do the heavy lifting. They give us data, which is de-identified. We put it into the system. We create a unique ID. We send that unique ID back to every single, if it was a spreadsheet, let's say we add an extra column to the spreadsheet, and this includes a unique ID on our system, which they then record based on, they know patient number 1 or row number 1 was Mrs. Smith, row number 2 is Mr. Jones, etc. So they know who the individuals are. We don't. So every site is using our systems for debugging their own data, which is kind of nuts, but that's the way it seems to be. We can tell them all the people, men who are pregnant and 300-kilogram babies and all the random errors that exist in their data that just they didn't know about till they upload it to the system, and we wrote some software that can tell them all the bugs in their data. And then we get all these twice a year clean data from various sites, and when we do a range of things. Our funders, was Juvenile Diabetes Research Foundation, would only pay us when we had high quality, complete data. So this is kind of nuts. So we built all the system, but we only get paid if the data that we actually have in the system is good, which is not really our problem. It could be a hospital's problem, but we don't get paid if the data's not good enough. So clearly that's unfair, but it's kind of focuses the mind, I guess you can say, in terms of delivering on the system that you said you were going to deliver. So there are core data sets which we have to have, and they have to be almost complete. Say the BMI, or the body mass index, or the date of birth, or things like this. We have to have that. But there'll be other data sets which only a few hospitals collect, like retinopathy data or some other associated condition, which is in our dictionary, but most sites don't collect it. So we are benchmarked on the amount of patients in the system, as well as the completeness of the data. And then they can do all kinds of national benchmarking kind of stuff. So, the average so blood sugar, effectively, looking at how blood sugar is being managed by various sites over time, or which particular type of insulin is working or isn't working for which particular age group, et cetera, et cetera. They're the kind of things that the researchers want access to this data for. So the process generally is we have all this data. Researchers then will say, hey, I would like the average BMI for every child under 10. And I want that data. I need to know gender. I need to know yada, yada, yada. This gets approved by a committee of doctors who are associated with the project, and they say, yes, this is a valid research question. We'll give them an export of the data. So we then would just say, here's a zip file with all the, like a spreadsheet you wanted from all the sites. And the doctors are quite happy. They're publishing like crazy in all kinds of places, which is a good research project, which is all well and good. However, once that patient has signed that piece of paper saying, I'm happy to be involved in your registry, they're kind of out of the loop now. They have no idea how their downstream use of their data, what it's being used for. Should they have an opinion on it? Do they want to be involved in it? Is this something they're comfortable with? And so we need to factor that in because that's increasingly happening now. So I'll talk about in a tick, the individual's right to know about their data. What data exactly are you capturing about me or my child? How is it being used? What's it being used for? These are all things which people are very increasingly interested in. And also, especially with the sort of the security issues that have been happening in everywhere, cybersecurity incidents all the time, we can't take that for granted. People might have signed up to something 10 years ago and forgotten all about it, but it could come back to haunt them. This one-off consent is a broken model. So this idea, I approve, I don't really know what I'm approving for. It's a national registry for diabetes. Oh, it sounds like a good thing, but they don't really know what data we're collecting about them. If you try to say, here's the 500 data points we're going to collect on you, well, okay. So GDPR is a thing. I've just been told I've got 5 minutes. So General Data Protection Regulation is a European legislation coming in, which is really trying to put some more power in the hands of the individuals to know what data is being collected about them. Are they happy with that, etc. So we've been looking a lot into this. I have PhD students working on these projects as well. The basic idea is you have much finer grained control over what data is being collected by you. And if you don't like it, you can say, delete it. I no longer wish to be involved. Or if some researcher says, I want to access this data because I'm interested in some genetic aspects of type 1 diabetes, and we want to compare the dad who had diabetes with the child who has diabetes, they may say, no, I don't want that. Maybe the dad isn't the dad, who knows? But these are the sort of things. People should have much finer grained understanding to allow them to say, yes, you can use my data, or no, you can't, or forget me completely. I no longer want to be involved. So that's kind of what we're trying to do here. So how do we do it? I guess what we've been doing is my team build lots of mobile apps for medical. So we have cancer apps, we have all kinds of spinal injury apps, we do lots of mobile apps for patients to report. What are they eating? How are they exercising? How do I compare with everyone else? But put in the hands of the patients. There's a range of challenges with Mr. Apple, not so much with Mr. Google. Apple don't like apps which are targeted to specific subsets of the community. And this is a very specific subset. So anyone can download an app from the App Store, but if you can only activate it using, you are a patient involved in the registry, Apple generally are making it more difficult to do that. I won't go through the architecture, it's a basic web app with an API. First thing you do when you access this, you download the app from the App Store. The clinician will give you a code which is activated on the server. It says, okay, enter this string when you enter the app, when you start up the app, rather, and at which point the app now is activated, and only the clinician know that was Mrs. Smith, or Mrs. Smith, or whoever, and now they know that patient has the app. The patient's activated the app now, it's alive. When that patient starts using the app, or getting information from the system, we know who the app belongs to. They can record a whole range of they can see what data is being collected on them. They know they're tracking my BMI in this patient. This is actual real data, but it made it look like for me. But I got the techie to just say, give me someone's data and pretend it's me. So I've activated the app for me. So this patient's obviously having an increasing problem with BMI. And there's a whole range of data they can look into about the time history of their having diabetes. A researcher now, in this new world of patients can see what data and do they want to have access to share their data or not. The researchers now make a request to get access to the data. We run queries, on the left here, say how many patients meet the characteristics for that study. It might be boys with a BMI above 10 or whatever, or above 30 or something. We then say, okay, these are the 372 kids that may qualify for that study. Instead of just saying to the researcher, here's all the data, we now generate notifications to everyone with the app installed saying, are you happy that your data is going to be used for this specific study? Yes or no. So they can say yes or no, as the case may be. in which case we would then export the data from our system for everyone that said yes and give it to the researchers. But the patients themselves have now had a chance to say, I'm okay with this or I'm not okay with this. In this case, you see the individuals who've said okay to a few studies here, just to demonstrate it can be done. We have this very important button here called Right to be Forgotten, which is one of the main things about GDPR, I guess you can say. When you say, remove my data, it has to be removed straight away from the system. So where we are right now, we've built the prototype app. We are rolling this out now. We just, as I speak, in the next week, we'll have all the data from New Zealand in our system. So New Zealand has been our primary test case for getting all the data in for the next round. We are in the process now of dealing with the clinicians, because one of the challenges in this space, and I know it's not a technical challenge, it's the clinicians themselves are the gatekeepers. I don't know who these people are. Only the clinician who knows Mrs. Smith or Mr. Jones or whoever it might be, only they can create these activation codes saying, put this into this app, and we'll give you information about how your data is being used, which is great for the patients. I mean, my experience in building apps, mobile apps for patients, is they love them. Especially if they have a condition like cancer or diabetes, they want to use these things. They want to feel engaged with the research. However, the clinicians themselves, if too many patients start saying no, then that's going to screw up their research. They don't want that particularly. They want to use this data. They like the idea that it's all there and they can ask these big, rich questions. And so, yeah, I fully expect this will be a patchwork quilt of patients that get adopted. And eventually, as it nearly is in all my projects, eventually there'll be a critical mass of everyone else is doing it. Why aren't you activating your patients? We build sort of pie charts, and these are the clinicians that have the most patients that are being recruited, et cetera. And when we get together as a meeting, there's a kind of shaming people into submission almost. It's kind of, it works. And the final thing I'll just say before I stop is that at the moment, this is just passive. Patients get told there's a study happening here. Would you be willing to be involved? Yes or no? But they're not being asked to contribute data. So we build lots of machine learning and image recognitions, like what food are you eating or how many steps you're taking, which could be a much more active sort of level of patient involvement, where that data is also sitting alongside all the other clinical information that we're collecting. So this is first steps in the GDPR space, but again, I wait to see how it unfolds. I'm happy to take questions if there's time. Yo, fire away.
So you mentioned, well, before you started talking about the app, you started collecting information from the big hospitals,
Yeah.
patients in big hospitals, where you probably see a good cross-section of society at all times. Were you thinking about how you maybe wanted to maintain that with this app?
The patient data or the...
No, in some way getting patients to use the app selects or deselects certain types of patients.
Right now, we're just trying to get this app in the hand of as many patients as we can to get them to agree to how their data is being used. Because ultimately, there will be laws, privacy legislation's coming. And the very idea that we can just carry on using data because someone ticked the box 5 years ago is not going to cut mustard. There is laws coming in the privacy space about data management, especially in Europe, certainly. Lots of my European projects have this microscope on what data is being collected, where's it being sent, who's using it, are patients across, do they know their DNA is in Sweden or wherever it might be? So that kind of stuff is absolutely coming, and we have to be prepared for it.
Sorry, there's lots of questions.
Oh, I'll take one. She's come a long way. I want to hear Carol.
I've come all the way from the UK to ask this question. Very interesting, Richard, but it seems that you were passing raw data actually out to with patient, when you said you exported patient data.
Back to the hospitals.
Yeah, back to the hospital.
Yep.
Is that raw data?
Raw as in,
As in, actually, it's not aggregated data.
it's raw. It's raw data. So,
Okay, I can tell you in the UK that's
but it's
not-
de-identified at source. So all we know is that these are typically it'll be, tell me the age distribution. We need boys, let's say, of a certain age, or children taking a certain, or adults who have whatever the data dictionary is, they can ask questions of it. But with the system right now, what we have, You would never be able to re-identify the individual in our database once it's been added into it. You know year of birth. You know they have type 1 diabetes. You know the hospital that's treating them.
But you're moving the data.
We get data from source, comes to us, we aggregate it, we clean it, we debug it, we aggregate it all, and then a researcher says, I'm interested in all the kids with X, Y, and Z. Can I have that data? If there's only 3 kids, the answer is no. It's there's a chance of you re-identifying them.
Made me worried that you were moving data at one point.
No, we are. We absolutely do. That's kind of the gig. We get raw data from hospitals, messy, horrible data. We tidy it up. We give them IDs back. Some researchers then say, I want to have a question about all the data that you've integrated from all the hospitals now. How many patients meet the following? Could you give me a spreadsheet of that data? And that's what we do. But each one of those requests for all a cut of the data is assessed by a panel, and then we just export a query.
So you're actually a TRE.
Pretty much. There was another question, but I think I'm getting kicked off.